Welcome. In this session, we'll learn how to create multidimensional arrays in Matlab. Let's start. Let's open Matlab. This is Matlab. Now, before I illustrate how to create multidimensional arrays in Matlab, let's revisit how do we write arrays in Matlab. Before we write arrays, let's see, suppose we want to enter a constant. Let's suppose the value of this constant is 2. And the name of this constant is a. So this 2 is stored in variable a. Let's now create a row vector. So this is a row vector. Similarly, I can have a column vector. So this C is a column vector. Similarly, I can have an array of 2 by 3. So this is a 2 by 3 array. Similarly, I can have 3 by 3 array. Let's suppose the elements are these. So this is a 3 by 3 array. Now if I type whos, this will provide me the information of all the variables that are in this workspace. So type whos. Now this says A is an array of 1 by 1 order. That's what I said. Any variable or a constant declared in Matlab is stored as an array. So this is the proof. So even a constant or a simple value in Matlab is stored as an array. So A is a 1 by 1 array. B is a 1 cross 4 array. Similarly, C is a 4 cross 1 array. D is a 2 cross 3 array. And E is a 3 by 3 array. Now if I check dimensionality of all these arrays, so what I do, I type m dims. This is a Matlab inbuilt function. This tells me, this will give me the dimensionality of. So this tells me A is a two-dimensional array. You can check A is simply a constant. So even this constant value is stored as a two-dimensional array. Now let's check what's the dimensionality of B. This is again a two-dimensional array. And what's my B? B is a simple row vector. Similarly, if I type what's the dimensionality of C, this is a two-dimensional array again. And if I say what's C, C is a row column vector. Similarly, if I type dimensionality of D, again this is a two-dimensional array. And if I see what's my D is a 2 by 3 array. Similarly, I can check the dimensionality of E, and again it's a two-dimensional array. And dims means what is the dimensionality of this array, E. So now I see what's E. E is a 3 by 3 array. So these constants, row vectors, m by n arrays are simply stored as two-dimensional arrays in Matlab. Now the next question is, how do we create multi-dimensional arrays in Matlab? It's how do we create 3-dimensional, 4-dimensional arrays in Matlab? So this is our next topic. Now before I illustrate how to create a 3-dimensional and 4-dimensional array in Matlab, let's revisit how do we represent a 2D array in Matlab. For this, let me switch to another screen. Let me share a different screen. And suppose I have an array, and suppose the name of this array is A. And let's suppose the elements stored in this are 2, 4, minus 5, 3, 0, 7, 4, 2, and 1. So this is my 3 by 3 array. As we just saw, the dimensionality of this array is 2. So the dimensionality of this array is 2. Now, if I have to access any element, that's if I have to do the indexing of this array, how do I do that? I simply write the indexing of this. The indexing of 2 will be 1, 1, means if I have to access this 2, what do I write? I write 1, A, 1, 1. So this will refer to this element. So at 1, 1, this element is stored. So the indexing of 4 is 1, 2. The indexing of 5 is 1, 3, means first row, third column. Similarly, indexing of this 3 is 2, 1, means second row, first column. Indexing of 0 is 2, comma 2. Indexing of the 7 is 2, comma 3. Means second row, third column. Similarly, indexing of this 4 is 3, comma 1. Indexing of this 2 is 3, this is 3, comma 2. And indexing of 1 is 3, comma 3. So if I have to access any element in this, what I type, suppose I want to access this element, I type A, comma 2, means using its indexing. I will use the indexing of this. This is how we access elements in 2D arrays. Now to create a 3-dimensional array, this is simply an extension of 2-dimensional array. So to create a 3-dimensional array, we add additional subscript for indexing. That is how we create a 3D array. So we simply add one more subscript in indexing, and that will give us the 3-dimensional array. Now, before I do this in Matlab, let me show you one picture. What do I mean by increasing this indexing? What I mean by that, so what I do, I simply increase the indexing. So what is done on this page, what I have done, this is the first page of that 3-dimensional array. So this is the first page of that 3-dimensional array, and you can check this is a 2-dimensional array in itself. This page is a 2-dimensional array. We know M by N array is stored as a 2D array in Matlab. So what I do, I increase one more subscript, and the subscript that is added here is simply this. So first page is referred by this one. This means first page, first page. Similarly, this means second page, and second page. In other words, when I am adding one more subscript to this 2D array, I'm increasing the pages. Similarly, this is the third page, third page, third page. So that's how we extend the concept of this 2D array to 3-dimensional array. So what are we doing? We're in terms of this indexing, we are increasing one more subscript. And that means what we are doing, we're adding pages. In other words, what we are doing, we're adding more 2D arrays. And that gives us a 3-dimensional array. You can see, if I have to refer to any element on any page, what I do, I refer it by what is the row number, what's the column number, and what's my page number. So I use 3 indexes now. So 3-dimensional array is simply the extension of this indexing to 3. So if I have to access, suppose this element what's stored here, so I use third row, second column, and first page. Similarly, if I have to access this element, what I do use row number, means 4 here, column number 3 here, and what this is on page 2. Similarly, if I have to refer to this element, I will refer it by what's the row number, that is here, what's the column number, 1 here, and what's the page number, that's 3 here. So this is on page 3. So simply what we do, we are adding pages. What does it mean adding pages? We are, in terms of the subscripts, we are adding one more subscript to this 2-dimensional array. And what happens in terms of 2-dimensional array, you are adding more 2-dimensional arrays to this, and that gives this that gives us the 3-dimensional array. Let me share one more picture with you to illustrate how does the 3-dimensional array look like. And this is my 3-dimensional array. And see, now to illustrate this, if I have to access this element, if I have to access this, let me use this first. So if I have to access this element, suppose this 0 here, if I have to access this 0, all right, if I have to access this 0, what I do, I will refer it by what's the row number, what's my row number is 2, what's my column number is 2, and it's on page 1. So that's how will I access this element. Similarly, if I want to access this 3 here, so what I do, I type what's the row number. So the row number is 3. What's the column number? It's on third column. And suppose it's on page 5. Suppose it's on page 5. That's how I access the elements in this. I hope this picture is clear. In short, to extend to the array to the 3D, what we do, we add one more subscript. Now adding one more subscript in terms of this 2D array means adding more two-dimensional arrays. So in term, if you visualize that this is a notebook, so 3D is a notebook, what you are doing, we're simply adding more pages to this notebook. So if you have a single page of the notebook, that's a 2D array. Now if you add 2 pages to a notebook, that means this is a 3-dimensional array with 2 pages. So, and if you have 3 pages, that will again remain as 3-dimensional array. If you have 4 pages, that will again remain as 4 pages. I hope that's clear. So this will still remain as a 3-dimensional array, no matter if you had billions of pages. So this will give you 3D array. Similarly, to extend it to the 4-dimensional, what you will do, you will extend this, you will add one more subscript to this 2-dimensional array. So what you will do to extend this 2D to 3D, what you do, you add one more subscript. Sorry, let me use this. Let me use the general. So what you do, you add row number to access. So this is the column number. All right. So if you have now, if you want to access any element, suppose I want to access second row, third column on page. This is how we access the elements in 3D array. Now, if I add one more subscript, that will give me 4D. For example, if I say row 2, column 3, and if I say page 1 on 3D, and I can add page second of 4D array. So if I add one more subscript, this will give me 4-dimensional array. So to make a 4D array in Matlab, what you do, you add one more subscript. It means you extend the 3 subscript to 4 subscripts now. This is how we build multi-dimensional arrays in Matlab. I hope this concept is a little bit clear here. Now to build a 3D array in Matlab, let's take an example. Let's switch to Matlab. Let's see how do we build a 3D array in Matlab. Let me switch to Matlab and let me clear the screen. Let's suppose A is an array with elements this 6, 7, 8, 9. So this is my array, and if I check dimensions of this array, this is a 2-dimensional array. And if I type size of this array, this will give me the size, meaning number of rows and number of columns of this array. Now to make it a 3-dimensional array, what I'm going to do, I'm going to extend one more page on this. So this will be my first page. This is my first page. Now I want to add one more page. Now to add one more page, what you have to do, you are going to have all rows and all columns on that page and add one more page, meaning a second page. And let's suppose the elements on this will be 10, 11, 12, 13, 14, 15, 16, 17, 18, and sorry, I did all right. I did something here wrong here. I have to put a semicolon. So this you can see is a 3-dimensional array now. Now let me clear this and type this. Now I have 2 pages of this A array. So before I add one more page, let's see how do we access elements in this. So if I have to access this element, what I do, I write A. What is the row number of this? This is second row, second column, and what's the page number? This is page 1. This will access this element. So I want second row, second column on page 1. Similarly, if I have access this, let me say third row, first column, and on page 2. That means I'm talking about this element. This should give me this element. So if I enter, this gives me 16. Sorry, this gives me 16. Now if I check dimensions of this, this will be a 3-dimensional array now. So I hope the concept is clear. Let me type this again. Now, if I want to access any element and I want to change that element, suppose I want to change the second row, third column element on page 2, I want to make it to -5. Will this do? Now you can see it changes that element to -5. Earlier it was 15, now it's -5. So this is how we access the elements access on this three-dimensional array. Now let me add one more page to this. So let me add one more page to this. So I will add third page, and what I'm going to do, I'm going to use MATLAB's inbuilt function. Now ones means all ones. So if I type 3, this will be a 3 by 3 array. Means if I type ones here, this will be simply a 3 by 3 array. Let me show you first this. What do I mean by ones? 3. It means this will be 3 by 3 array where all the elements are equal to 1. So that's the meaning of ones. This is again inbuilt MATLAB function. Now what I'm going to do, I'm going to add this on third page. Ones, 3-dimensional. So let me, I will write this. All rows, all columns on page 3, and the number will be this. So you can check, let me go back. So this is my A. If I check the dimensions of this A, it's again 3. What you have done, you added third page. So on the first page, these are the elements. On the second page, these are the elements. On the third page, these are the elements. Now if I want to change this element, well, how do I do that? I write A. What's the row number? Suppose this is the second row, second column, and on third page, and I want to make it equal to 0. And this is 0. You can check if this makes it equal to 0. That's how we access the elements on a 3-dimensional array. So I hope this is clear. Now let me add one more page. All rows, all columns, and give me fourth page. And I will use MATLAB, MATLAB's another inbuilt function that's called zeros. Now zeros simply gives you all elements in this array will be 0. And if I type zeros 3 means this will be a 3 by 3 array. This will be a square matrix 3 by 3. So on page 4 of this A array, I will have all zeros. So you can check all the elements are 0. Now if I want to change this element, what I can do, I can write A, suppose 2, 3, on page 4, make it equal to -1. Okay, I did it wrong. This is a syntax error. Sorry, this is on page 4 is equal to -1. So now you see I changed the element on page 4 to -1. So this is how we access elements on this 3-dimensional array. Now, if I type dimensions of this, see I have 4 pages. This will be more clear to you, but this is again a 3-dimensional array. This is not a 4-dimensional array, although you added 4th page. And so this is again a 3-dimensional array. So what you are doing, you are simply, if you are using only 3 subscripts, that means this is a 3-dimensional array. No matter what will be the page number, you can have billions of pages here. Let me add one more page. Let's suppose I add one more page to this, all rows, all columns, but I want 5th page, and 5th page should be I. What do we mean by I? I mean is identity matrix. So this will be a 3 by 3 identity. So the 5th page is, first page is this, second page is this, third page is this, fourth page is this, 5th page is this, and so on. If I still check the dimensions of this will be still 3, not 5. So that's meant by, this is how we create multidimensional arrays in MATLAB. I hope this is clear. I hope this is clear by now. So this is how we access the elements on this 3D array. And similarly, you can extend this concept to the 4D, 5D, 6D. So what you have to do, you have to, extend means extend the number of dimensions. So what I can do, suppose all rows, all columns, and first page, what you do, you add second column, and suppose I want this 2, and if you type this will be a 4-dimensional array. You can check this is a 4-dimensional array. You can check this is a 4-dimensional array now. Let me clear this again, then type A again. You can check. Now let me show you what's A. On page 1 up, on page 2, on page 3, on page 4, on page 5. Now on 4th dimension, of this second page means on fourth dimension, these are my these arrays, and these are all zeros actually because I didn't assign any array to it. Now, please repeat this yourself, how to extend this to the 4D. This is very easy. Repeat the same procedure, how I did it for 3D. But what I'm going to do, I'm going to do this procedure by using Matlab's inbuilt function. I'm going to define an array B, but I'm going to create a 4D array, but using Matlab's inbuilt function that's called a repeat matrix function. And this is Matlab's inbuilt function. And suppose the element there is 2. And what I want 2 rows, 3 columns on each page, and I want to extend this to the 4 dimensions. So this should give me a 4D array where all the elements on each page should be equal to 2. That's what I'm doing. Means there will be 2 rows, 3 columns, and on page 4 dimension it will have 4 pages. Now let me check it. Okay, so you can check. There are 4 pages on the 4th dimension, but all the elements are same. This is very simple example. Now if I type end image of this, let me type end image of this. So this is B. So this should give me 4. See the dimensionality of this is 4. You can type the size of this B. This tells you there are 2 rows, 3 columns, and there are 4 dimensions. Means on dimension 3 there is only 1 page. On dimension 4 there are 4 pages on 4th dimension. This is how we extend the concept of 2D array to the 4D array. I hope this is clear. I hope this is clear. I hope this is clear. Now finally I want to conclude this session by very important command in Matlab. That's actually the Matlab's inbuilt function. I want to show the functionality of that. That's called a reshape function. If you have any array, let's suppose I have an array X, and let me take a very simple example. Let's suppose I have this 6 by 6 identity matrix. Identity matrix is a square matrix, so obviously the dimension will be 6 by 6. So this is my 6. Now what I want to do, this is just an idea. This is just an idea. What do we mean by reshape and what it does? Suppose I want to reshape this matrix. There I chose the identity matrix. You can have any matrix, and this can be an image. And remember, image is itself a matrix of numbers that we shall see later on, hopefully. So I want to reshape this X matrix, X array. What I want to do, I want to have now 9 rows, but only 4 columns. How many rows are there? 6. How many columns are there? 6. So, but I want to reshape this X array to 9 rows and 4 columns. So how do I do that? I think I did it wrong. I didn't type reshape. Sorry, I didn't type. So reshape this. These are the arguments. First is the array which you want to reshape. Then next is the number of rows you want to have. And the next is the number of columns you want. Now you see, this has reshaped this array. Please practice it. This is very, very important for image processing. This is very, very important for image processing and data science. This reshaping function is very, very important. That's why I illustrated it here. Take examples yourself and see what do we mean by reshaping. Take several examples for this. Now I hope that this idea of multidimensional array is clear in MATLAB. What you do, if you add more subscripts, means you are indirectly adding more. If you go from 2 subscripts to 3 subscripts, what you are doing, you are adding pages to it. In terms of 2D, you are adding simply the pages, 2-dimensional pages to that array. Now you can do that 4th dimension also, you can do that also 5th dimension, 6th dimension, and so on. I hope the indexing is clear on this multidimensional array. Let me end this session here. Let's